So, AI is literally everywhere, right? We hear about it constantly, but what does that actually mean? How are we really trying to make machines, well, intelligent? Today, we're going to pull back the curtain and look at the core ideas behind AI. And it all starts with one single question that kicked off this entire crazy field. Think about it. Before you can even start building an intelligent machine, you have to decide what you're aiming for. What's the goal? What does success even look like? This one massive philosophical question is the ground zero for artificial intelligence. And right away, it split the early pioneers down two completely different paths. So you've got these early researchers, and they had to make a choice. What should thinking in a machine actually be? Were they trying to build a perfect copy of a messy, emotional human mind? Or were they trying to build something else entirely? That choice created the two great schools of thought in early AI. And this was the great divide. On one side, you have the imitation game, which you might know from Alan Turing. The goal here is simple. Can an AI act so human that you can't tell it's a machine? But on the other side, you've got the logic machine, or what we call the rational agent. Its goal is not to be human. It's to be perfect, to be perfectly logical, to always make the absolute best, most optimal decision, even if that seems kind of cold or robotic to us. Now, that whole imitation game thing, super cool, but a huge amount of AI's actual practical progress has come from that second path, the mission to build a perfectly rational agent. So, how do you even begin to do that? Well, the very first step is you have to give the machine knowledge. But what does it even mean for a machine to know something? Okay, so this is where we got to pop the hood and look inside the AI's brain. We're going to see how it stores and organizes information. Because it can't just have a random jumble of facts in there. It needs a system, like a really well-organized digital filing cabinet, to make any sense of the world. And here are some of the key tools you'd find in that filing cabinet. An AI could use really simple if-then rules to capture basic knowledge. If the light is red, then stop. Easy enough. But for more complicated stuff, it might use a semantic network, which is kind of like a mind map. It connects concepts, showing that a canary is a bird and is yellow. Each of these methods gives structure to raw data, so the machine can actually use it to reason. Let me give you a classic example of these tools in action, something called an expert system. One of the most famous ones was called Mycin, built way back in the 70s to diagnose blood infections. The creators literally sat down with doctors, interviewed them for hours, and turned their entire diagnostic process into hundreds of if-then rules. And get this, in some trials it actually performed better than the human experts, which just showed how powerful this kind of encoded knowledge could be. Okay, so our AI has knowledge. It's got all these facts neatly filed away in its digital brain. But that's all passive, right? It's just sitting there. How does it use that knowledge to actually do something? How does it make a plan and go achieve a goal? Well, the way an AI acts is by turning pretty much every problem into a search. Just imagine you're solving a Rubik's Cube. The scrambled up cube, that's state A. The perfectly solved cube is state B. Every single twist and turn you make is a move through this enormous state space of possible combinations. The AI's job is just to find the quickest, most efficient path from A to B. But you can imagine checking every single path for every problem would take, well, forever. That's where something called heuristics comes in. A heuristic is just a fancy word for a smart shortcut or a rule of thumb. When your GPS finds the fastest route to your destination, it's not calculating every possible road in the entire world. No way. It's using heuristics, like highways are probably faster, or let's avoid areas with known traffic, to make an educated guess and find a great route, fast. So this whole search for a solution eventually builds into a full-on plan. A planning system is like the AI's personal to-do list generator. It looks at the end goal, it looks at all the actions it's capable of taking, and it figures out the exact sequence of steps to get the job done. This is the part of the AI that turns the what it wants to do into the how it's going to do it. All right, now we are about to take a huge leap forward. Everything we've talked about so far involves an AI that is programmed with knowledge by humans. But here's the catch. You can't possibly write rules for every single situation in our incredibly complex world. So, what if the AI could just learn on its own? This right here is where modern AI starts to feel truly intelligent. And there are basically three main ways machines learn.
First, there's supervised learning. That's where you feed it a ton of labeled examples, like thousands of pictures of cats, all labeled cat, until it finally figures out how to recognize a cat on its own. Then there's unsupervised learning, where you just dump a mountain of data on it and say, go find something interesting. And finally, you have reinforcement learning, where the AI learns by trial and error, kind of like a puppy getting a treat for doing a good trick. It gets digital rewards for actions that bring it closer to its goal.
And then there's this absolutely wild approach that's straight up inspired by biology. A genetic algorithm works just like evolution. It starts with a whole population of possible solutions, it scores how fit each one is, and then it lets the best ones reproduce by mixing and mutating their code. Over thousands of generations, the solutions literally evolve to become better and better. It's a true survival of the fittest, but for solving problems. How cool is that?
All right, so our AI can know things, it can plan, and it can even learn. But let's be real, the world isn't all ones and zeros. It's messy, it's ambiguous. So the final frontier, the real next level, is teaching an AI how to operate in all those gray areas of human reasoning.
And this is where something called fuzzy logic comes in. It's a way for an AI to handle ideas that aren't a simple yes or no. Instead of the temperature being either hot or not hot, fuzzy logic lets it be somewhat hot or a little bit cold. This is so much closer to how we humans think intuitively, and it's used in everyday stuff like a washing machine that can sense how dirty the clothes are and adjust the wash cycle all by itself.
And that really brings us full circle, doesn't it? We've gone from simple if-then rules all the way to systems that can learn, evolve, and even handle ambiguity. As these systems get more and more powerful, the question of what makes us unique becomes less of a technical problem and more of a really deep philosophical one for all of us to think about. Thanks for joining me for this explainer.